Alright, let's talk today about sequences. So we have two types of sequences we're going to go over, and that's arithmetic and geometric. So to be arithmetic, you have to add by a constant. Number. So you could add, add 2 repeatedly. You could add a fraction repeatedly. So we could add 1/4 repeatedly. We could also add a negative. So we could add -5 repeatedly. So whatever you're doing, you have to add the same number over and over again. For geometric, you have to multiply by a common factor. So just like our arithmetic, we can multiply by 2 repeatedly. We could multiply by, 1/4 repeatedly. That means our number is going to be getting smaller because we're multiplying by a fraction. You're not actually dividing, you're multiplying by a fraction. And we can multiply by a negative number, which is going to make your numbers flip-flop as you go. So one's going to be positive, the next one's negative, then positive, then negative, so on. And I'll give you examples of all of these. Alright, so let's look at a couple examples. So the first one I have there is 7, 11, 15, 9 for our sequence. So to get from 7 to 11, I'm adding 4. To get to 11, 15, I'm adding 4. And to get from 15 to 19, I'm adding 4. So that makes this arithmetic. And then we can come up with the next 3 terms by continuing the pattern. So we're going to add 4 to 19. So we'd have 23. Oops, wrote that wrong. Said it, but didn't write it correctly. So 23 plus 4 would be 27. Plus 4 would be 31. Alright, so our next sequence there, we have 3, 9, and 27. So to get from 3 to 9, I would add 6. To get from 9 to 27, I would add 18. Well, I'm not adding by a constant factor, so it can't be arithmetic. So let's look at multiplying. So 3 times 9, 3 times 3 is 9, and then 9 times 3 is 27. So this is geometric, because I'm multiplying by 3. And then I can continue that to get the next 3 terms. So I'm going to do 27 times 3 to get 81, and then times 3 to get 243, and then times 3 to get 729. Alright, so let's do a few more examples. So I have 1 and 25 hundredths there, and then 1 and 4 hundredths, 40 hundredths. So to get from 25 hundredths to 40 hundredths, I'm adding 15 hundredths. To get from 40 to 55 hundredths, I'm adding 15 hundredths. And to get from 55 hundredths to 70 hundredths, I'm adding 15 hundredths. So that makes this arithmetic. I'm just going to abbreviate here. So to keep that pattern, I'm just going to keep adding 15 hundredths. So that would be 1 and 85 hundredths, and then 2, and then 2 and 15 hundredths. Alright, for the next one I got 64, 32, 16, 8. So I'm obviously not adding anything there because it's being cut in half each time. So really what I'm doing here is multiplying by 1/2. So I'm multiplying by 1/2, that makes it geometric. So I'm going to keep doing that. Half of 8 is 4, half of 4 is 2, half of 2 is 1. I can keep going. Half of 1 would be 1/2. Half of a half would be 1/4. So you can see that you can get answers that are decimals, you can get answers that are fractions. It's just, are you adding by a constant factor or multiplying by a constant factor? If you're doing neither of those, then it's neither geometric or arithmetic. So let's do one more example. Alright, so I got 3, negative 6, 12, negative 24. So you can see I'm obviously multiplying here because the numbers aren't going up by just 3 each time. So what am I multiplying here? So to get from 3 to a negative 6, 3 times 6 is 2, and then a positive and negative make negative. So I'm multiplying by negative 2. Well, let's see if that applies to the next one. Negative 6 times negative 2 is positive 12, so that worked. And then 12 times negative 2 is negative 24. So my pattern there is multiplying by negative 2, so that makes it geometric. And then to get my next terms, I'm just going to keep multiplying by negative 2. So 24 times 2 is 48. Negative and negative make positive. 48 times a negative 2 would be 96. And positive and negative make negative. And then the next one times 2 would be 192, and negative make positive.